Hello and welcome. We're back to question 2 at Leaving Cert Ordinary Level 2023 Paper 1 Maths. And today's question is a complex numbers question. Let's read part A. Plot Z1 bar, which means the conjugate of Z1. So that means that it's the image through the real axis. So we can see that Z1 is equal to 3 minus 3i. So Z conjugate will be 3 plus 3i. So we're going to plot it in up here directly on the mirror image. Z2 and Z3 are two other complex numbers. We need to plot those in as well. So we can see Z2 is 5 plus I, out 5 up I, and just put in Z2 here. And Z3 is out 6 down 2. So label them with the underscript. Now let's write 4z minus 5z3, okay, in the rectangular form a plus bi. So we're going to work it all out through algebra. So let's substitute in the z2. So we have 4 by 5 plus I minus 5 by 6 minus 2i. So the only difficult part here now is just the two minuses. Just have to be careful there. So our new number will become 20 plus 4i and minus 30. Distribute in your minus and we get a plus. So we get plus 5 by 2, which is 10. So we have 10i. So ultimately we'll have 20 minus 30 is a result of minus 10, and 4 plus 10i will give a result for 14i. So that's your complex number in a plus bi format. Now the next part is to find the modulus. So let's look at the modulus. So z is equal to a plus bi in rectangular form. When you apply the modulus, we will get the length from the origin. So we need to square up both coefficients. So we have a squared plus b squared, and we put it under square root. All right, so let's get our z3. And you can see we have 6 minus 2i. So we can take out the numbers. That's a and that's b. So we can see we're going to have z3 modulus is equal to the square root of 6 squared plus the minus 2 ought to be squared. Put in your brackets with the calculator. Be careful there. And then we get a result of 40 within the square root. Look up now and we can see that it's in surd form. So that would be something like a root b. So press change in your calculator and we will get 4 by 10, which is going to be the square root of 4 is 2 and square root of 10. Now finally, we have to identify the complex number in the graph with the largest modulus. Okay, so the modulus is the distance from the origin out to the points. So we can measure here, it's very obvious that Z5 is the largest modulus, and the reason, just state that it has the greatest distance from the origin. And that's it for the question 2.